guys, so today we're going to be working on the Valid Anagram question. So we have two strings S and T, and we should return true if the two strings are anagrams of each other, otherwise we return false. Basically, an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. So I have these two examples. So we have for this example here S and T. We return true because we have these and these, like the anagrams of each other. They have exact same length and exact same characters of each other. So like these will have the same thing as this, and these same thing as this. So you get what I'm saying? And like this second example here, we return false, so we can see they are not anagrams of each other. So S and T consist of lowercase English letters. So basically we have two solutions. Like have this first solution, and I'll try and have another one later on. So the first thing we should do, I think we're going to compare the lengths of both strings, right? So basically, like if the length of S is not equal to the length of T, we should return false. So sorry. So then we're going to convert the strings to character arrays. So we just have these. Let's just call these S array, and we'll say like S to character array, right? And we do the same thing. Let's just do the same thing for T. Sorry, I'm lazy. That's why I'm copying and pasting. So I have these. So after that, we're going to sort both arrays. So like we can have so like the comparison is going to be like easier, right? So we're going to like sort these out. So have like A, C, E, then R. Do the same thing for these, and then we're going to compare the two of them. I don't know if you get what I'm saying. So let's just write it out. So just say array dot sort, and do that for S array, and do that also for T array. And after we're done, like we'll compare both arrays. So let's just do S array dot sequence. So typically this is the method that's going to help us like do the comparison between like both arrays. So and these will return us a boolean. So if these and these match, it's going to return true. If that's not the case, if they don't match, it will definitely return false. So we can just say return here. And having these algorithm will have like time complex of big of n log n, right? Also our sorting, and we'll have like space complex of big of n, big O of n. So let's just run these out and test. Basically, we need to have like a much more efficient, solution. So let's just get rid of this, and we'll jump into our board. Like we have like some explanations. So basically we have these. We need to find out if these string and these are anagrams of each other. So we'll create a dictionary. Typically in our dictionary, what we're going to do is that to store like, let me just write this. So we'll create a dictionary just for like count like the elements in S and have like the number of time each letter occurs inside. I don't know if you get what I'm saying. So basically we'll have a loop, and we'll go through all the elements. So yes, this is S, so this S. We'll check for R. We'll come inside there. We're going to add all of them inside this dictionary. So we'll add R, right? Go to A, we'll take A, step inside, write A. So basically this is 1. So I had the value 1, A as appears 1 time. We'll do the same thing for C, 1. Do the same thing for E. So I hope you get the idea. So sorry if the sketch is like messy. Like E, I have like one time. We have C, we come here again. Since we have C here already, we're just going to add it, we're going to increment and have 2 here, right? A, do the same thing. A already existed, so we just put 2, right? Increment and R, going to have R, we already had R, sorry. So we just have 2 here. You just increment, right? And basically what we're going to be doing is that we also have the T elements, right? We're going to loop through all of these elements. And basically what we're going to be doing is that for every element, we'll come into this dictionary and we're going to see, okay, if it exists already, we're going to decrement like the count. So C is here already, so we're going to decrement these. We'll have like 1. We'll have 1 until all of them are 0. And we do the same thing for A. Go to A. A becomes 1, right? Sorry if all of this is just messy. I just hope you follow along. Go with R. Let me just, oh sorry, let me just have it wall like R. We'll check for R. Sorry, really sorry if this is messy. I'm messing up around. So we just have 1 here. We do the same thing for these. As you can see, R now here becomes 0, and like all of them have to be like 0, like the count for all of them have to be 0, right? So this also A, so this becomes 0. C becomes 0 too, and we have E. We'll check for E here, and E is also 0. So E is also 0. Alright, and basically if this is the case, we've tested like all of the elements, we've just returned like we return true, right? And another condition is going to be like we're going to check if we have like, we don't need to like have like negative. So let's say we had another element here. Let's just take these. Let's just take I don't know why this is behaving like this. I don't know what I'm doing. Alright, so sorry, I had a small problem with this. So basically, let's say we had another like value in T, right? Let's say we had another A, right? So typically we'll be testing these again. We're coming here again to our dictionary and we're going to be checking. So come here and do 0 minus 1, which will give us a negative value. And if we have these, want to have these, we're going to be returning false, right? So we're going to return false. Same thing if we had like, also going to be returning false. If you had like, let's say let me just erase like A, and we had something like let's say T, right? And we'll be checking inside this dictionary and we'll see we don't have T, so definitely we're going to be checking it also, and since we don't have it, we're going to be returning false. I hope this makes sense. Alright, so let's jump back into the code. So typically what we're still going to check for, like, the lengths of S and T, right? And if they don't match, we'll return false. Then we'll create a dictionary and have like a character and the number of time the character appears. So have these, right? Then we're going to loop through all the elements, like in S, and typically we'll do these. Let me just write it out, then I'll explain to you. So get the value or the default value, right? For L, default will be 0, and we'll add 1 to it. So typically we'll take the element, and if it doesn't exist in dictionary, its default value is going to be 0, and we'll add 1 to it. If it already existed, like we take R, you find R already. The first time we have like 0 plus 1, have like 1, and the second time we come, we'll say 1 plus 1 here, so it gives that's going to give us 2. I don't know if that makes sense. So now we're going to have another loop, and we're going to go through all the characters in T, right? And we're definitely going to check if there's an element or a character inside T that does not exist inside dictionary, and if that's the case, we typically return false. So we just check. So as count contains key, right? So if it does not contain that, so if there's something in T that's not inside our dictionary, so we return false. So otherwise we're just going to decrease the value, right, by 1. Then we're still going to check if, like, let's say the value or number of time the character appears is negative. If that's the case, we return false. I don't know if all of this even makes sense to you. So definitely when all of that is done, we return true at the end. So speaking of time complexity, we'll talk about big of n, right? And speaking of space complexity, since we had this constraint here, we'll talk about big of 1. So let's run these